The power of trig. Now, what is the power of trig? Let's see. Watch this. Go ahead and draw a simple right triangle for me like this. Do it with me. You're about to see some crazy stuff right now. Let's go ahead and make this angle. Let's pretend this angle is 13 degrees. Go ahead and put a 13 there. So far, so good. Now, on your screen that I trust you have on, let's go ahead and go to your scientific calculator that we've been doing for the past 2 days. Go ahead and have that screen in front of you open, please. You're about to witness something huge. I'm talking huge. Trust me. Trust me on this one. It's so powerful it might even scare you, Ariola. Watch this. You ready? Medina, what's the weird word I've been saying for the past? We've all been saying this weird word. It starts with a T. It's a certain ratio. The what ratio?
Jack.
Whoa, that was scary. You're scaring me, Ariola. T-A-N. Okay, now, that word tangent, there's a button on this calculator that has T-A-N. Can you see that button? Okay. Go ahead and press that button for me. And then go ahead and press, what was the degrees of that small angle you just drew? 13. Go ahead and press 13. Hit enter. Language, please, thanks. Now, watch this. The tangent of 13 degrees, watch the power now, watch. The tangent of 13 degrees, here's the ratio. You and I have been, we've been estimating these nasty long ratios to the 4th decimal, right? So this would be 0.2309 if I were to round to the nearest 4th decimal. Now, here's what I want you to write now. Have that screen in front of you. You have your notes in front of you. Watch what I'm going to put, watch. Watch this. Here's a magic. Here's a power now. Underneath that picture, you're going to write the tangent of 13 degrees stay with me, nice and big. The tangent of 13 degrees is always, forever, without fail, no matter what. I'm serious. Watch this. The tangent of 13 degrees is always, forever, without fail, no matter what. Can someone, you got the screen in front of you. Was what? 0.0 what? Give me the, give me.
I swear that's what it came out.
Well, what's it?
It's 0.2309.
09. Okay, put a big fat star here. Look at, put a big fat star there. There's the power. The power is that statement. Underline forever. Underline always. Underline without fail. Underline no matter what. That fact that the tangent of 13 degrees is always going to be 0.2309. This is what this means. Watch, check this out. Look at this small right triangle that's inside the big right triangle. Here's a magic now. You got to focus now. If you focus here, the rest is going to be a piece of cake. Watch. The tangent, remember, was the side that's opposite over side adjacent. What if I have a smaller right triangle? Look at. This is still 13 degrees. Guess what? This side that's over adjacent is still going to be 0.2301, 0.309. So how about a smaller one? This side, the opposite over the adjacent, is still going to be 0.2309. How about the smaller triangle? This side over that is going to be 0.2309. In other words, no matter how big or how small the right triangle is, if you have a 13-degree angle here, it's always going to be that ratio. Now, knowing that, look at the types of real-life situations we can solve. Has anybody been to raging waters? What do you say? What do you say? Who used to work there? Check this out. Oh. No. Watch this. Don't write anything down. I just want you to focus and pay attention to this raging water situation. Check it out, Reels. So, there's a person, I'm not sure you can see from where you're sitting. There's actually a person standing here. He's looking at the top of a water slide at raging waters. And this person wants to estimate how high the beginning of the slide is. So right here, how high is this off the ground? Look at H. We don't know how high it is. But this person does know this, that he is 58 meters away from the base of the slide. And he also knows, and look at this, what's this angle of elevation here? 13 degrees. So watch this. Without having to climb up this ladder or measure here, he's going to use trigonometry to figure out how high that slide is, just by knowing how far away he is from it with this angle. Watch. Here we go. I'm going to do it. You're not going to write anything down. Just focus. Ready? Here we go. Stay with me. The tangent of 13 degrees. What's the side that's opposite to 13 degrees right now? What side is opposite? H. Look at this. H over, what's the side that's adjacent? 58. Look at this equation. Behold the equation. I'm going to find out how high that slide is just by getting H by itself. How would I get H by itself? How would I get rid of 58? Think of math 1. Thank you. Look at it. I'm going to multiply 58 on the right. Don't write this down right now. You're just focusing and watching me. And I'm going to multiply by 58 on the left. Watch what happens. Stay with me. This is the same as 58 over 1. By, look at H is by itself. Look what I have on the left side. This is funky statement saying 58 times the tangent of 13. What the heck is that? Wait a minute. You and I just typed in tangent 13 on our calculator. It came out to what? 0.0 what? So H then, the height will be 58 times 0.02309. And we'll know the height. Look at it. Because remember the tangent of 13. Remember the tangent of 13 is this? It's forever, without fail, no matter what, that. So I'm going to multiply that by 58, and we'll have the height of the slide. Watch me. Watch the master. Stop laughing. Watch this. Look at it. So 58 times tangent of 13. Let me get my calculator out. Watch the way I'm going to calculate on my calculator, because you're going to be doing this on your own. Watch this. 58 times tangent 13. I'll hit equal. 13.39, so that's how many feet, or actually how many meters high the slide is. I'm going to round the nearest first decimal, so about 13.4 meters. So look at this slide then is 13.4 meters high. So I was able to calculate the height of an object in space without actually having to directly get a measuring tape and climb up the ladder or the slide to figure it out. Now imagine the power of this if this triangle gets bigger. I can calculate stuff higher than the slide. How about if it gets way out here? How about where it gets to the stars? How about it gets to galaxies? We can use triangulation. We call this trigonometry. We can calculate the height of stars using trigonometry. Because all we got to do is know the distance from here to here. And it doesn't matter how high this is, because these right triangles will always be the same if this is 13 degrees. That's the power of trigonometry. Let's try example 1. Go and write this down. Example 1. Want to write that triangle down, please? Well, we're going to practice now. What I just did on my own with you watching, we're going to do together now. We're going to form some trigonometric equations. Say again? So is this one number 2? Well, remember the other one had 13 degrees and 58.
Oh, okay, thank you.
You with me? It had a degree and a side. Gotcha. Go and copy that down. We're going to write solve for x. Let's solve for x. Can we use Pythagorean theorem? You sure? Give me an argument why not. What if I said, yeah, we could? How would you prove me wrong? Hold on, let's go Rios and you. Go ahead. Okay, I like that. Try again though. Castillo? Yeah, it does. Look at this A, 40. It doesn't have B. It doesn't have B. So what? Huh?
It doesn't have.
Yeah, it does. Yeah. What if I say, hey, I want to forget you. I want to use Pythagorean theorem. Who are you to tell me I can't? Say again? But I want you to prove why I can't with an argument. Gonzalez, I thought you had some. Remember Pythagorean theorem 3 weeks ago? A squared plus B squared equals C squared. We use this to solve for missing sides. My question is, how would you prove to me, or with a logical argumentation, why can't I use this for here? Well, those x's with Pythagorean theorem. Say it again? Well, I know my A, I don't know my B. Well, let me respond. I do have an A, I don't know my B, and I don't know my C. So why can't I use this? Right. In order to use this, okay, in order to use this, I got to know 2 of the variables, at least 2, to solve for the missing. Here, on this example, I only know one side, which is 40. So I can't use Pythagorean theorem. But we don't have to, I didn't hear it then. Sorry. It's no good if you say it and I can't hear it. Relax. So Pythagorean theorem only works if I give you 2 sides. Like let's say I gave you this with 80 or something. Then you can use Pythagorean theorem. But if I only give you one side, no hope. But there is hope with trigonometry now. Here we go. We're going to use the tangent ratio. Watch this. Tangent, write this down. What's the angle we got? 58, huh? So this one is not 13 degrees like the raging water slide. This is 58 degrees. But guess what? The tangent of 58 degrees is some eternal ratio that never changes. That's always the same, without fail, just like 13. Every angle has its own ratio. That's forever true. So does 58. So now, what's the opposite of 58? Thank you. What's adjacent? We're rocking and rolling. Look at it. Let's get x by itself now. By? You're awesome. Multiply the right by 40. Multiply the left by 40. Watch this. By to that. Bring down the equal sign. Basic equation. X is, look at x is already alone, which is what we want. Go ahead and type this garbage in your calculator, please. Just like you see it. Please do that for me. It's important garbage. 40 times the tangent 58. Type that for me, Rios. Come on. Work with me. Type that puppy in. Quick. What do you got? Franco, hit it. So let's see, 64.01. Let's go to the nearest 10, so 64.0. X is approximately 64.0. I round to the nearest 10, the first decimal. Yeah, that was really tough, just punching buttons, wasn't it? Don't worry, practice makes perfect. Actually, not perfect, better. So we're going to practice. So just punch that. Did you get this though, Medina? You punch that? You got that? Sure does. Get it. Practice this. Right now, I want you practicing that on your own. 40 tangent 58. Do that for me. Make sure you get 64 point something. If you're there, you're with me. Right, because when stuff is next to each other, it automatically means time's up. So you don't have to put that. You with me, Sylvia? Aguiar, you with me? Gonzalez, you with me? All right. Let's go on example 2. By the way, we solve for x. Yeah, 64.0. This side is 64.0. Done. Someone answer that for me. That's why. Good, Medina. That's classic Medina. Here we go. Example 2. Where we at? Here we are. Example 2.
How many examples are there?
Go write this down.
This is the power, all of this.
Right.
Oh, we have to hit the real power.
Well, Rios just asked a great question. So this is the power. The power is we can solve for missing distances indirectly. I can solve the height of a building just by knowing how far away from the building I am. Whether it's a skyscraper, whether it's a blimp, whether it's a jet, whether it's a star, whether it's a galaxy, I can calculate the height of something just by knowing one side and then the angle of elevation. That's the power of it. And that's just the tip of the iceberg. When you get to calculus, the uses of trigonometry is just unbelievable. Unless you want nightmares. All right, what's the acute angle I'm given here? 30. The mission is to solve for x. Why can't I use Pythagorean theorem? We only know one side, it's square root of 3. We need two sides to use Pythagorean theorem, but no worries, we know trigonometry now. We know the tangent ratio, so write this with me. Tangent, 30. Stay with me, gentlemen. Got this down?
Yeah.
Cool.
I was just saying negative.
So tangent of 30 is opposite of 30, x again, adjacent, rad 3. Let's rock and roll. Let's get x by itself. How do I get x by itself? By rad 3, huh? Careful there. Let's multiply by rad 3 on both sides. Watch this, you guys. It does, because 3 is different than rad 3, huh? It's an irrational number. We did that week 1 in here. That's 4 weeks ago. Oh, no. Watch this. Bye-bye to that. Right? Yeah, okay, that's logical. X is on the right. Type this garbage in there. Radical 3, tangent 30. Do that for me. Say again? Exactly 1? Sounds good to me.
I got 1.31607.
We put rad 3? No, you put everything radical. It's only the square root of 3. Only the square root of 3. It's not the tangent. You put, look at, you put this. You did this. Right, you got to put parentheses. Let's space. It's not the square root of everything. It's only the square root of 3. So type in rad 3, tangent, 30 degrees. You don't have to. You can just separate the square root.
Oh yeah, it comes out 1.
1. Let me try it. Let me try it. How about that? Let's try it. Let's try it. So watch this. Rad 3. Rad 3. Then I'll press the side of it to get it out of the radical now. And then go tangent. Was it 30?
Yes.
Yep, exactly 1. We're rocking and rolling. We're rocking and rolling. I'm telling you. But that Mr. will get really a curveball now. It's a piece of cake now, But now, here comes the curve. Let's see if I strike you out. Take questions, Medina? Go ahead. Go ahead. Example 3, here we go. No, too late. Sorry. Here we go, example 3. I'm going Dodger blue again. We're on a roll. I gotta stay with blue. Last one for today. Last example. This example involves an extra 2 stamps if someone can actually solve for x here. That's not fair because I don't get to win. Nice one, Medina. Go ahead, Sylvia. Yeah, watch. Look at it. I told you I'm gonna throw a curveball. I'm not sure if you're aware of this, but Mr. Mugi used to be a pitcher. He's not just some nerdy math teacher. Frank already sees a curveball. All right, watch this. What's my acute angle? Gracias. What's opposite to 45? What's adjacent to 45? Okay, let's do it. Right, here's our equation. Write it with me. Tangent, 45. Cool, so far so good. Piece of cake. Opposite to 45 now is 9. The denominator is the unknown now. Okay, now, let's see. Should I go with 2 stamps or a free assignment pass? Okay, 2 stamps. Help. What do I do? What do I do here? Okay, wait, let's go Rocha and Rios. Wait, what's your, flip what? Talk to me. Flip it? Like, willy-nilly? Okay. I'll come back to you. Well, let's go one at a time. Rios. Okay, so you don't know? I thought you're going to try some.
I did try.
But that was like 3 things. Divide out. I'm with you. Just give me some, though. I'm just not against you, man. Okay, multiply by what? Okay, by x? Okay, multiply both sides by, so whatever I do to one side, I do the other because of the equation. So let's multiply both sides by 9. Let's see. Let's see if he's right. If he's right, he gets his 2 stamps. No, don't write this down. If it's right, we'll write it down. Let's see if Rios gets 2 stamps. Watch this. So on the left side, Rios, come on, let's do. So on the left side, I got 9 times the tangent of 45. On the right side, this is 9 over 1, right? So let's see, what's 9 times 9? I have 81 over x. So it didn't really get us anywhere, huh? Good try, though. Okay, wait. We had a line here. We had a line. We had Mr. Castillo. Okay, never mind. All right, Sevilla, hit it. Hit it, Sevilla. Okay, who's next? Two steps. Wait, let's go Leviera, then Rocha, then Medina. Go ahead. Both sides? Okay. You're disqualified.
Oh!
It's going to be all right, though.
That means you're wrong.
Watch this. So whatever I do to one side, I have to do to the other. So that's exactly, so I'm going to divide both sides by x. Let's see what happens. On the right side, 9 divided by x is really 9 divided by x times 1 over x. This means the same as this. On the left side, I got tangent of 45 divided by x. Let's see what we got. Let's see how Naviera gets it. So I got tangent, I'll keep this the same over here. Divided by 9, or actually divided by x, my bad, this is x. Let's see, 9 times 1 is 9, x times x, x squared. It's a little more nastier than when we started. Good try, though. All right, hold on. Let's see. So right now, what's giving us trouble, the curveball that I'm throwing at you, is that we have an unknown on the denominator. What do? Sevilla, save the day. Okay. Don't write it down yet. Let's see if he's right. Then we'll write it down. Okay. This is 45 or 1. So what's 9 times 45? So I'll put 400 something over x equals 45 times 40. Yeah. X is still the denominator. Sorry. That's a good algebra erasing.
What if you like substitute X?
How do you get rid of?
Wait, let's see. Who's next in line?
I got this on by.
Castillo has his hand up. Hit it.
How was
So what do I do to both sides one more time? Divide by 9 on both sides. Here we go. Uh-oh. Let's see if Castillo got this. Uh-oh. So 9 divided by x divided by 9 is really 9 divided by x times 1/9 equals tangent 45 divided by 9. Let's see what we got. Let's see where we're at now. Let's see if Castillo gets this. Numerator times numerator. Denominator times denominator. 9x, huh? So these cancel out. So on the right side, I really have 1 over x equals this. So x is still in the denominator. Good try. Anybody else?
you really catch like
Hold up. Hold on, real quick. I'm going to lift up the ante now. One free assignment now. Who can tell me what to do? We just get. Wait. He's all. Hang tight. You already had 2 tries. Anybody else want to try? Free assignment pass. Go ahead. Uh-oh. Let's see what we got. So we got on this side, we have 9 over x minus x over 1. On this side, we have tangent of 45 minus x. Unfortunately, these are not common denominators, and when I do get common denominators, I'll still have an x on the denominator. Good try, though. Say it one more time, Adina.
Is it like a secret math?
Oh, no, you got to use trigonometry.
Oh,
It's actually a basic algebra skill. Whatever you do, hold on, let me talk. Whatever you do to one side, you got to do to both. What should we do to both sides to get this freaking x out of the denominator? Let's go Ortiz and Sevilla. Hit it. Wait, one thing. Gotta give me one thing. Hit it. Okay, let's see. Language, please.
you should be disqualified.
So on the right side, I'll have 9 over x minus 45 over 1. So these are not common denominators. I'll have to get common denominators, and when I do that, I'll still have an x on the denominator. Good try.
You want a free time?
You're getting tired, aren't you?
Yeah.
Well, that's because.
How do you get rid of this? Tell me that.
Well, I still got takers here. Not everyone is as annoyed as you are. Relax. Sevilla, hit it.
45.
Good try.
Can you give us a hint? It's like a little sprinkle.
You got to do something to both sides. You got to do something to both sides.
You gotta divide it by.
You got to do something to both sides.
Add 45.
Should I make it worth 2 assignments? How about this? 1 whole assignment and 1 quiz, free quiz at 100%. Any quiz you wanted. Okay, never mind, dude.
You look like throwing. Keep Because you know we're not going to share it.
I'm trying to be nice, Medina. Come on.
All subtract.
Say it again?
45.
Good try.
Hey, subtract tangent 45.
Good try.
Negative 45.
All right, one more minute, and I'm gonna do it on. I'll get the free assignment pass. Libya, one more time. That'd be adding x. Go and do it. Good try. That's the same what he did. Subtracting a negative x is the same as adding an x. Get it?
Make it a 1x.
X is 1x. Rocha, you're alone, son. Anybody? 30 seconds. 30 seconds. So multiply by what on both sides?
All right, it's 45. Multiply 45.
But we'll just have, I think someone said it because 9 times 45, the numerator would be some 400 something, I think. Yeah. Okay, here's a hint. Here's a hint. You have to do something to both sides.
No, other than that.
Yeah. Not really. Not really. Right now, I want to get the x out of that dang denominator. Just take it out. Like, what do you mean? Like just flip a fraction willy-nilly? Well, we can't just take a number and just flip it because we want it. There's got to be some logic to it. Why would we flip it? Are we going to divide by that number? Somebody, you know. By?
Didn't you say when there's like next and everything choose x or 1?
There's a 1 coefficient. You can't just change an x to 1. That's an unknown number, but there is a 1 in front of it, is what I mean. There's always a 1 in front of it, but x, we don't know what it is. That's what we're trying to figure out what it is. All right, time's up, you guys. Sorry. All right, Medina, you ready? You Googling it? It's going to be all right. Watch this. All right. So let's see. So before I give you the answer, example 2, x was on top. Example 1, x was on top over here. Yeah, there's x on top. But what's troubling us right now is x is on the bottom. Here's what we do. I'm going to multiply both sides. No. I'm going to multiply both sides by x. I knew someone's going to say, I did say that. No, no, you didn't. You said x over 9 or something. You didn't say x. Sorry. Yeah, this is something that made it. All right, so go ahead with me on your notes, the last one for the day. Go and write x on the right, multiply x on the left. Stay with me. Here we go. Watch this. Give me a chance. Phony Mugia. Watch me. Watch. Bring out the equal. X's are gone because this is x over 1. That's gone. And so I have 9 over 1, which is just 9 on the right side. Nice. On the left, I have x times the tangent of 45. That's kind of funky. Our goal is to get x by itself. Nice. Wait a minute. Rocha's on it. This means x times tangent of 45. Tangent of 45, remember, is that some ratio that's always never changes, forever the same? In other words, if you punch that in your calculator, you get some funky decimal. It never changes. In other words, this is a number. Tangent of 45 is some ratio number. So if it's x times that funky number, how would I get rid of that number? What do I do to both sides to get rid of the tangent of 45? Wait. This is multiplication. What's opposite multiplication? So go like this, go like that, go tangent of 45 on the left, tangent of 45 on the right, by to that on the left. Look at x is all by itself on the left. We're rocking and rolling. Type this crap in your calculator now. 9 divided by tangent of 45. Give it to me, somebody. 9 divided by tangent 45 on your calculator. 9 point what?
Nine.
We solve for x.
That was like.
It makes no sense. Pure logic. It's all sense.